Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is Grumpy Bookstore Owner. Okay, so you will be there is a bookstore owner, okay, who has a store open for 10 minutes, okay, and every minutes uh, some of the customers enter the shop, okay, or the store, and the customers array is all you are given a customers array representing the customers entering on the ith minute. So every index in the customers array is representing the number of customers that will be entering on that particular time. Okay, so let's say the customers I the number of customers at the ith index of the customers array represent the number of customers that will be entering the shop at the ith minute. Okay, so all those customers will live at the very end of that minute. Okay, so let's say at the first minute some 5 customers entered. On the start of the second minute, okay, or when the first minute ends, all those customers will leave the shop. Okay, so this is what the problem statement is telling us here. And on some minutes the bookstore owner guy is grumpy. Okay, so how we will be knowing that the bookstore owner guy is grumpy or not? On that particular on that particular minute you will be given a grumpy array, and for that particular index in the grumpy array, if the value is 1, it means that the shopkeeper will be grumpy on that minute. So if at the ith minute, ith entry in the grumpy array, the value is 1, it means that at that particular minute the shopkeeper will be grumpy. Okay, and if it is value is 0, then it means that he will be in normal mood or a happy mood. Okay, so when the bookstore owner is grumpy, then in that case the customers of that minute are not satisfied, otherwise they are satisfied he if he is in good mood, which is by represented by grumpy array value being 0 at that particular minute or that particular index, you can say. So the bookstore owner knows a secret technique to keep himself grumpy for some minutes, consecutive minutes. Okay, but he can use that technique only once. Okay, so then what you have to do is you have to return the maximum number of customers that can be satisfied throughout the day. Okay, so this is what problem statement is asking us. And before thinking of an approach, let's try to have a look at the constraints also. Okay, so according to the constraints, the length of the customers array and the grumpy array will be both n and equal, and that will be, and the number of minutes for which the guy can remain in a good mood, consecutive minutes, that by using the technique he have, uh, and the number and the size of the customers and grumpy array will be of order 2 into 10 raised to power 4. Okay, and each value for the number of customers entering at the ith minute will be of order 1000, and each entry, as it is already told in the problem statement, in the grumpy array will be either 0 or 1. 0 representing that he is in good mood, and 1 representing that he is in grumpy mood. Okay, so these are the constraints. So let's see how we can approach this problem. Okay, so let me clear about little bit. Yeah, I think it's here now. And just a little touch here. Okay, now we are good to go. So what the problem statement is asking you to do, in a way you can say that you will be wanting to find the window of size m minutes where m is the, this value. If we take an example, one of these examples, so is minutes value. Okay, the number of minutes in which the maximum number of customers who will enter the shop will be getting dissatisfied. Okay, so in a way we are trying to save the maximum number of dissatisfied customers, uh, okay, as much as we can. Okay, so as it is already told that for m consecutive minutes shopkeeper have a technique that he will remain in a good mood. Okay, so you can say that shopkeeper will generate a kind of a window for m minutes, okay, in which he will remain in good mood. Now he will be wanting to greedily generate that window in the interval when maximum customers are entering, which who will be getting dissatisfied. Okay, so the, so I hope you are able to understand the maximum number of customers who will get dissatisfied will enter. Okay, so we already knowing from these two arrays, this is the customers array by the way, and this is the grumpy array. Okay, so we will already know that which customers will be getting dissatisfied, okay, by the help of these arrays, and the shopkeeper will be wanting to uh, you know get as much as dissatisfied customers in his this time frame or this window, good mood window, you can say. He can use this window only once. So a very intuitive way after seeing or making these observations is to use sliding window technique. Those of you who are hearing it for the very first time, I will add the link of an article to slide of describing about sliding window. Okay, and when and how to use it. Okay, and basic implementations. So you can definitely check that out if you are not familiar with it. So now coming back to the problem statement, what we will be doing here is, as the name suggests, sliding window. So this is our window. It will be of size m minutes, okay, or size m, okay. And here let's say we are taking the very first example. Here the minute size is 3. So your m value is 3 here. So you will be having a 3 size window, something similar to this. Okay. So now what you will do? So you will be wanting those positions at which the customer is dissatisfied. These positions. Okay. These positions you will be wanting to check. Okay. I'm marking those positions. So you might be wanting to find out the dissatisfied count. Okay. Dissatisfied count and maximum dissatisfied count. Okay. So you are wanting to have this. Okay, then you will be adding overall total number of happy customers, total happy customers, plus this value, maximum dissatisfied count. Let me take another color here. So maximum dissatisfied count. So you will be wanting to take these values. Once you are having this sum, then you will be returning it, and it will be your answer. It is that simple. And now talking about what will be the use of this window. So this window will keep sliding by one position ahead. Okay. So now next position of this window will be this one. This much area it will cover. Next time it will be different. So next time it can be, let's take this color. Next time this will be this. So as you can see, if we try to make a observation, what is the position of this window at which maximum customers will be, you know, getting dissatisfied. So this is that position 5. uh, so how many number of customers will get dissatisfied here? 6 customers. As you can see, these two values add up to 6. So 6 customers will be getting dissatisfied. So this is the maximum dissatisfaction you can get. Okay. Now we will just add total number of happy customers. So let's mark those customers. So these are happy customers. Okay, those are not indicated or joined by the red ones. So these are all happy. So it is 7 plus 3. So 3 ones, as you can see, 1, 2, and 3. So in total, 16. 16 customers will be the number of customers that the shopkeeper can greedily satisfy. So in a way, we are using this sliding window for a greedy algorithm. Okay, greedy algo, kind of a greedy algo. Okay, so he want to maximize something, so it usually comes under greedy. Okay, so this is the technique that we will be using. Sliding window is just a fancy name. I hope you are able to understand that we are having some size. Okay, and how we will be achieving this window thing. So we will be using two pointers here. It is a kind of a two pointer technique. Let's say this is the window. So there will be one pointer which is left, which is marking the start of the window, and there is one other pointer which is right, which is marking the end of the window. Okay. So every step you will increase your right pointer, and whenever the window is complete or the size is equal to m minutes, and then you will shift your left pointer by just 1 point. As we told, this window will keep moving by one, one step at a time. So this is how we will be achieving this, and more will be clear in the implementation part. Now, without further delay, let's have a look at the implementation also. So let's take a fresh slide. So this is the implementation. Okay, and so as I talked about, that you will be having two pointers, left and right. This will be the start of the window, and this will be our end of the window. Initially, they both will lie at the very first index, which is the 0th index. Okay, so we are in process of forming the window, or you can say, in a way, we are trying to inflate the window to its desired size. So now window is shrinked to this, so we want to achieve this. Okay, and this size is nothing but minutes. Okay, its size is minutes. Okay, or you can say m. So we some first of all we want to inflate the window, then we will keep moving this window one step at a time. Okay, so this is what we are trying to do. So we will be having one variable, dissatisfied sum. Okay, so dissatisfied sum is the sum, the number of customers, dissatisfied customers in the current window. Okay, so number of dissatisfied customers. Pardon please if some spelling is incorrect. I hope it does not affect your understanding of the approach. And number of dissatisfied customer. Okay, so in current window, specifically in current window. So this is that. number, number of dissatisfied customers. Okay. Now maximum dissatisfied customers, maximum dissatisfaction sum. Okay. Throughout the movement of this window from one position to the other position. Okay. In the array. So total happy sum. Okay. The total number of customers who will be happy, uh, at which that shopkeepers will not be grumpy. So this was your happy sum, if you ask me. This was your happy sum. You take some other color also. This was your happy sum. Okay. So this is that variable. Now we are just applying this sliding window. So your left will be going till, let's say you are having 5 size array. Okay. And your window size is 3. So let's this form a 5 size array. 0, 1, 2, 3, and 4. Okay, this is the 5 size array. So 5 minus 3, what it will be? 2. So the 2 will be the last index on which the left pointer will be. Okay, and your right pointer will be obviously here, and your left one will be here. So this is the basic check that we are having for the exact boundaries of the window till where it will be going to the right hand side of the array while starting from left to right. In this fashion it is going. Okay, or if you want to change some color, it is going in this direction. Okay, so first of all you will see what is the number of customers that the right pointer is pointing. Okay, so the job of the right pointer is to bring customers in a way, and the left one's job is to leave behind the customers who are no longer part of the current window. Okay, leave behind the dissatisfied customers, to be specific, who are not part of the current window. So then there will be one variable is grumpy. Okay, so it is a boolean variable. We will be wanting to find out whether at this particular instance, or the current index, or the minute which at which right pointer is pointing to, the shopkeeper is grumpy or not. If he is not grumpy, then you can add that to the total happy sum, the customer numbers. And if he is grumpy, then you will add that number of customers to the dissatisfied sum for the current window. Okay. So now once you have inflated your window to the desired size, which is equal to minutes, then you will keep updating this maximum dissatisfaction sum, or the maximum dissatisfied customers. Okay. So we will keep updating that with the current number of dissatisfied customers. Okay. Once we have done that, for each step, as I told you, the window will slide one position ahead. So if let's say window is here, okay, then after the next step it will be here 1, and then this will be 3. So this 0th position was left behind. So how we will be achieving this? This will be achieved by moving left pointer by one position ahead and decrementing the value from the current dissatisfied sum if that particular customer was dissatisfied. So if that particular customer on the left, to which left pointer is currently pointing to, is dissatisfied, we will uh, you know those decrement those particular customers from the current dissatisfaction sum. Okay, otherwise we are good to go. Those were already happy, we are fine here, and we will anyways be incrementing our left pointer, which will be it at this particular new position. Okay, so I hope till now it's clear. And every time you will be incrementing your right pointer, since right pointer will continuously be moving. Okay, whether your window is inflated or strict. Okay, it really does not matter. So right pointer will be always incrementing, and it will always stay ahead or equal to left pointer. And so this will be the thing that you will be returning: total happy customers plus the maximum dissatisfaction sum that you can achieve. Those number of customers you can obviously satisfy readily. So this is the whole approach. And if we talk about the complexities, let's take a fresh slide, or let's discuss here itself. I think there is some space left here, or let's clear this thing up. Okay, so now it's clear. Just a second. Okay, so time complexity wise, it's order of, let's say the size of these two are n, so it will be order of n, as we are just doing a linear traversal here of the array. Space complexity wise, as you must have seen that we are using only pointers and some variables, so it is pretty much constant, so constant extra space. Okay, so linear traversal here, because of that you are only having of time complexity of order of n, where n is the size of the customers array and the grumpy array. Okay, so this is the whole approach and implementation also. If you are still having any kind of doubts or any queries in general, then please feel free to ask them in the comment section. I hope this solution walkthrough added some value to your journey of honing your DSA skills. And till then, keep practicing and keep solving more problems. I will see you in the next video. Thank you for watching.